This is the white belt video for class 7. The activity is going to be the database interaction activity, and the exercise is going to be shareable packages. If you're not familiar with databases, I want to go ahead and spend some time walking through what databases are and how they work. Databases are probably, outside of code itself, the single most common resource that we access in applications. So it is really important that you understand databases. There is a file called databases, how databases work, inside the files that I've given you. So definitely pull that up, kind of follow along. But I've got that file here. So let's think through, what is a database? I want you to think of a database like a spreadsheet, like Excel or Google Sheets, with multiple sheets or tabs. A database represents data in rows and columns, very much like that, but the tabs and sheets are going to be linked to each other. So imagine we're dealing with a company that is managing employees and sales. Here's what this structure might look like. I'm going to zoom in a little bit to make this a little easier to read. So the sale table might have an ID column, a date time column, and a salesperson ID column. These would be the column names at the top. The data types for those ID might be a number, the date time might be a date, and the salesperson ID might also be a number. And then we might have an employee table, so a different table, different sheet, where again, the columns would be ID, first name, last name, maybe social security number. We've got the different data types here. You'll notice that there's this line between them. This is denoting that there is a relationship between them. And that is, this salesperson ID is a relationship to employee ID. This is a one-to-many relationship. So in other words, a single employee, that's the key here, can have many, that's the infinite sign on its side, can have many sales. But a sale only responds or corresponds to a single employee. So this is a one-to-many relationship. This is a foreign key relationship between these two tables. So note that the columns have a name and a data type. And so the data might look something like this. Let's imagine the employee data first. Maybe we've got record 1, record 2, record 3. And you could visualize this again as a spreadsheet. We've got the first name, we've got the last name, and we've got social security numbers. Superman's social security number is not on file yet. Maybe he hasn't gone to the social security office yet, as he is still working on his immigration paperwork. Then sales, that data may look something like this. So again, we've got our IDs, 1, 2, 3, 4, 5. They're just incrementing numbers. We've got the date and time of those sales. And then we've got the salesperson ID. The salesperson ID is the ID in the employee table for that sale. So in other words, these first two records were sold by Mickey Mouse. It's a quick lookup from 1 to 1. This next record 2 was sold by Donald Duck. And then Mickey Mouse, and then Donald Duck again. So that's basically how these tables work. This is an example of what you might see. So again, you can imagine if this were in a spreadsheet, this is how the data might look between those two tabs, between those two sheets, and how they relate to each other. This is very similar, not exact, but very similar to how databases store their data so that we can retrieve them. So how do we read the data? So that's how it's stored. How do we get access to that data? Well, to do that, we use select statements. Selects are how we read data or retrieve data or select data out of a table. So here's some examples on some of these. Select star from employee. Star means all of the columns. So it's just a quick denote to say, give me every column. I could say, let's go to the employee. I could say ID, comma, first name, comma, last name, comma, social security number. That would be the same as star in this particular case. And we're saying from employee, that's the employee table. So that needs to match the name of the table that I've got up here. So the first one says, give me all the records and all the rows from employee. Give me all the employee data. Next one, let's say we want to get employees where the last name starts with M. So that would give us Mickey Mouse or Superman. We would say, again, select start, so give me all of the columns, all of the information. From employee, where, so the where clause is how we filter what we want. Where last name is like M%. Percent is a wildcard character. Wildcard meaning it can be anything. So it says M and then anything after it. So this is a starts with. If we wanted ends with, we would flip these. We would say percent and then M. That would be anything in front of it and then M on the end. Or if we wanted to say contains the letter M, it would be percent M percent. So just sandwich the in between them. That would be anything that has the letter M inside the name. So this is get all employees where the last name starts with the letter M. Next one, get employee names without a social security number. So we're going to say select just the names, first name and last name. We're only interested in the name. We don't want the social security number or the ID. We're going to get that from employee. You'll notice this one I am formatting differently. I'm putting the from and the where on multiple lines and indenting them. That's just for readability. It doesn't matter if you do it on a single line or you do it on multiple lines. SQL syntax is going to read those the same. Oftentimes, the bigger statements you're going to see on multiple lines like this just to help make it a little more readable. So again, from employee, where social security number is null. So we're using the is keyword here to find null. You can't use equal because null in databases works a little differently than you and I are used to in the programming world. So this is where there is no social security number. Let's get the sales in March. So we're going to select everything from sale. So star from sale, give me all the sales data, where date time is between March 1st of 2026 and April 1st of 2026. So there's a between operator built into Database World where we can give it two values. It will convert these to date times for us and then do the comparison. So there's all the sales in March. Let's get the sales specifically for Mickey Mouse. We're going to get sale and star. So this is interesting. This is not just star. We only want all of the columns specifically for the sale table. We don't want the employee tables columns. So we're only getting sale star. If we did just star, that would also give us employee data. So give me all the sale rows from sale, and we're going to interjoin employee. So in other words, we're going to link those two tables together as we retrieve the data out. We're joining on salesperson ID to employee ID. Well, that's this foreign key up here. So salesperson ID to employee ID, that is the actual join that we want that mirrors this relationship up here. So that's exactly what we're doing. So we're saying join on sales.salesperson ID equals employee.id, where employee first name is Mickey and employee last name is Mouse. So we're doing this join so that we can use the employee table down here inside our filters. So this is an even more complex query, and they get way more complex than this. But that's the idea on some basic select statements. How do we get data out and what's happening there? There's lots more examples out there. You can use the internet to basically learn more. How do we change data? Now that we know how to store data and we know how to get data back out, how do we change the data that's there? There's three different statements we use. We can add data, so new rows, by using an insert statement. So again, everything is done at a row level. So you can insert a new row, you can update an existing row, or you can delete an existing row. So the insert statement looks something like this. Insert into employee, and then the column names that I'm specifying, first name and last name. The values of those, Wonder and Woman. So Wonder is going to be first name. It's positional. It means whatever's first goes to whatever's first. Woman would be the last name because it's also positional. It's going to the last name. If I wanted them to be in the reverse order, I would simply reverse the column names and then the values. Another example, let's insert into the sale table. There's a new sale. We're going to insert date time and the salesperson ID. The date time is going to be the current date. So the current date on the server. The sales ID is 1. Mickey Mouse sold another sale. Great. Updating. So we can update using the update syntax. The update statement is a little bit different than the insert statement. We're going to update and then say the name of the table. Then we use the set keyword to say all of the different column values that we want to set. We're going to set the social security number to all threes, where the ID is 3. This is Superman's ID. So we're going to give Superman his social security number finally, which is 33333333333. So that's a simple update statement. This next one, we're going to update the sale table. We're going to set the salesperson ID to Superman, where the salesperson ID was 2. That was Donald Duck. Poor Donald Duck got all his sales assigned to Superman. So that's what's happening here. We're updating the sale for all of the records with ID 2. So this one, there's only one ID 3. But this statement here we're updating, there could be multiple IDs of 2 because that's not a guaranteed unique column. So this is going to give all of the ID 2s now the value of ID 3. So those are some update statements. Finally, let's look at removing data. So we're going to delete from employee. So delete employee where the social security number is null. We're going to delete Superman's record. He's the only null one in there. If Wonder Woman were in there and she had a null, she would also be deleted. So this is going to delete those rows out of the employee table. The last example is delete sale. Careful. This deletes everything out of sale. This is a mass delete. You're going to lose all of your data. If you don't have a where clause, you're going to drop all your data. So be very, very careful about your delete statements. That's basically the idea of databases. Hopefully that helps you, get you some understanding. We do this kind of select, insert, update, delete in as a part of code. You're going to be doing that in the activity in today's class. So hopefully that helps. You can definitely do internet searches, whether it's an AI search or it's a Google search or a Bing search or whatever your favorite search engine is. There's lots of information to get examples on how to do these. Feel free to use those, but hopefully this helps you give some background and some context. So from here, go ahead and pick your language. Start looking through the README files, both for the activity as well as the exercise. If you get stuck, definitely take a look at the YouTube videos and reach out if you got questions.